So first I'm going to put you to sleep as you watch this double pendulum simulation, and then my talk will be over. I'm from Canada. Last year I started working on this project called Plotly, and before I started doing software I was an electrical engineer, and I was using tools like MATLAB and tools like Igor Pro, and I found kind of over and over in the places that I worked that we're starting to bring in other tools to the mix. So some folks were using Python. I started switching over to matplotlib. Other people I was working with were starting to use R and ggplot. Some folks were being really trendy and using Julia. And other folks were just using Excel. Like, we're totally terrified of programming. And the problem with this was that we were all, at the end of the day, just dealing with graphs and dealing with data. And we were using all of these programs in all these languages that were totally incompatible with each other. So I would make a graph in MATLAB, and I'd take a screenshot of that graph, and then I'd send it as an email attachment. And that's like totally unacceptable today for the web. Like, you don't send a photo with an email attachment, you upload it somewhere and you send a link. But all these new types of web standards, I felt like, hadn't really come yet to data analysis, into engineering, into graphing. And so last year, me and my brother and a couple of friends, we started working on this project that we call Plotly, that tries to make graphing and data analysis cross-platform and puts it entirely on the web. So I'll go through some examples. Here we are in IPython, and we're using our favorite plotting library, matplotlib. And we have this graph, and it's looking great, and then we want to share that graph. What we did at Plotly was we wrote a wrapper that extracts all of the data behind that matplotlib graph, extracts everything about the matplotlib graph, like the style and the colors, and then we redraw it. We wrote our own graphing library, and we redraw it with d3.js. And now we have this version of this Plotly graph. So here's the matplotlib one. It has this figure. And then if you want to send it to Plotly, redraw an interactive version, you just call iplot MPL from matplotlib. And here's a new version of the graph. It's totally interactive. You can cruise around. You can pan. You can see the values on hover. And this graph is saved in my online Plotly account. So if I want to dig into this data, or someone else wants to dig into this data that I'm working with, they can click this link, and here's a unique URL where this graph will always live. And not just the graph, but also the underlying data behind that graph. So if your workflow involves sharing graphs and sharing data, you no longer have to say take a screenshot and then export that data to a CSV or an Excel sheet and then upload it to Dropbox and send like an email with 7 attachments and 4 links and like totally incompatible with each other. You can just do it in one place with Plotly and send this link, and then they can check out the data, they can check out the plot. So this interface that we wrote for Python, we decided to extend to every other language. So maybe you're working with someone who is checking out Julia, and they're using Julia and they're using IPython for notebooks. Then they can make an equivalent Plotly graph in the Julia language and have this really nice interactive version. And at this point, when I'm checking out this graph, it doesn't really matter what language this graph was made in, and it shouldn't really. It just matters that I can view this graph and I can view the underlying data behind this graph, and it's easy to share. Maybe you're working with someone who's using R and ggplot, and they're creating these really cool graphs, and they figured out how to get R to work with IPython. It's pretty easy now, and they're writing some ggplot code, and then they want to share that graph with you. The same sort of thing. They can just convert this ggplot figure to a Plotly figure with 1 line of code. So I'll just do this so that you guys believe me. Here we are in R, and we'll create this like really canonical R plot. looking good. It's a static version. In my old job, I would maybe take a screenshot of this and upload it to Dropbox. And now I just call ggplotly instead of ggplot with this figure. And if the network holds out on me, which I really hope it will, it'll create this ggplot figure online. I have a version in my Plotly account I can just pull up. If I was on the internet. You get the point. So, here we go. Well, it would create an equivalent ggplot figure online, my Plotly account, with the underlying data behind that figure. As an electrical engineer, I did a lot of work with MATLAB. It was like the first programming language that I learned. I loved it. And we wrote a similar figure converter, convert your figures from MATLAB to online Plotly graphs. Here's this static version of this MATLAB graph, and you can just call fig to Plotly, and it'll take that MATLAB figure, it'll convert it to an online Plotly graph. It's interactive. You don't need MATLAB to view this graph. You don't need to download a .fig and then open up MATLAB and then cruise around in it. Anyone can view this graph just with their web browser. That's why JavaScript is so awesome, because everybody has an interpreter on their computer. All they need is an internet connection, and you can share graphs and you can share data. And so this was really exciting for us last year, and we thought, we want to extend this to other people who maybe aren't technically competent and are really scared of programming, and wanted to make better tools for just making and sharing graphs online for people who are mostly just skilled in something like Excel. So you can, any type of Plotly graph that you can create in matplotlib or ggplot, you can also just create with our online interface. So here I uploaded a CSV of data, can make a scatter plot, select my 2 columns, graph it, maybe I'll add a fit to this data. It looks kind of Gaussian, so I'll draw a normal curve, and then here's a fit of this data. I didn't have to write any code to do this. Any of my colleagues could do this workflow. They don't need to be an expert in numerical methods or NumPy or MATLAB. And then when you can save this to your online Plotly account, and all of your graphs are stored online, and you can share these graphs with other people. You can give other people permissions to share them or to edit them. And everything about a Plotly graph you can edit either in code or you can edit inside our web app. So here's a graph that someone might make, and then I'll just fast forward through some changes that you can make, and all these little micro changes to the graph. You can have like a pretty publication quality interactive graph you can make pretty quickly without having to write code if you don't want to, or if you want to, you can write code and do it too. At the end of the day, you're making really great graphs online. And since we started working on this about 1.5 years ago, we decided to just make it free and put it online and make it public. And we just pushed all of our code as soon as we wrote it. And we've seen this incredible number of people come to make graphs online, from data journalists making graphs. Here are some engineers. And we created this feed to show off all the types of activity that was going on the web, of people uploading data and sharing graphs, and made it more of this like social experience. Sort of in the same way that like GitHub really socialized coding, we wanted to do maybe the same thing with graphs and with data. And so we've seen all these people create these incredible graphs, all the way from high school students who are making their first graph in their physics classroom, and they're making their first line of best fit, to folks like at NASA, who are using like matplotlib and then creating graphs and sharing those online. there are a lot of really cool scientific graphs that I was making in engineering school with programs that were really expensive, like MATLAB, which was $2,000, or Igor Pro, which makes these wonderful publication plots, but it's totally inaccessible to anyone who doesn't have a budget for scientific tooling like that. And then there were, on the other side of the spectrum, great tools like matplotlib that can create these incredible graphs, but kind of like inaccessible to those who aren't professional programmers. And then all these other languages that other folks were using that were completely incompatible. So these are the types of problems that I'm really interested in trying to solve now and improve the experience of people dealing with data in teams, trying to make a great graph and just trying to share it. Thank you so much for listening. Please try it out. I'm here all weekend. We were able to sponsor this event. And I'd love to talk to you guys more about what your data workflow is like, how we can make it better, make it less painful, and show you what we've been working on. Thank you so much. Any questions?
Thanks for that. That was really cool. Probably looks awesome. Matt, Sunquist emailed me a while back, asked me to take a look, and he's got a lot of my to-do list, but just moved up much higher.
Awesome.
So it's free at the moment, right?
Yeah.
Awesome. And you guys, is it always going to be free? Is it?
Yeah, we're going to structure it. We're structuring just like GitHub, so free for public use and for limited private use. So you can make like 20 graphs and 20 data sets privately for free. And then
currently set up? Have you got that?
That is currently set up. Yeah.
Working for you guys?
Mm-hmm.
Awesome.
Yeah. So, and then the other side of the spectrum is a lot of folks can't have their data, working at companies can't have their data leave the premises. So like financial institutions, engineering institutions, pharmaceuticals. And so we install Plotly on a private server at those places. It's kind of a great model because the folks that need to have their data private are usually the folks that have money to pay for tooling, and the folks that don't, like a high school student's never going to pay for some graphing software, but they can still benefit from all the tooling that we're building to build these kind of world-class tools.
Well, thank you. It's a brilliant tool.
You mentioned publication quality blocks. I would assume that we can download these in PDF, SVGs, so scale and all that.
Yeah, totally. So here's this graph, and I hope that maybe the network will be back, and it's at this URL. And if I want the SVG version, I can just add .svg to the URL, and then here's the static. Same thing with PNG.
Are you ever going to offer a downloadable format that encodes the graph and the data as well for offline backup? Because like spread service could be the same issue in any kind of online service, that I want a copy of my data. To you, I want a copy in case.
Right.
In case I need to go off in the middle of the desert where there is no internet.
Yeah, totally.
So do you kind of have a way to export the data and the graphs?
Right now, we don't, and we have kind of a lot of different ideas about that. Yeah, one version is just static.
Because an offline web page with the JS in the
totally. Yeah, totally feasible. Yeah. Absolutely. Yeah, and then the other thing we're working on, which is an open source project, is like making a cached version of the requests library. So if you are sending a lot of data over and over, you're making requests to Plotly and doing these streaming graphs, and then your network goes down, instead of just throwing an exception, caching those requests locally, and then retrying them when the network comes back up. Yeah.
That sounds good. It's a great piece of software as well.
Thanks.
Yeah.
But I guess as far as going into the desert is concerned, that would only be relative if you were using a web part, right? If I'm writing in matplotlib, I can go right down in the middle of the desert.
Exactly.
Have a draft of my paper with my own graph, and then throw it up.
Yeah.
I'm back.
Yeah, exactly. Yeah.
Looks like a really great tool. I mean, the way that you've been sharing graphs is one person will open up his IPython Notebook, everybody will sort of tap into his machines, run random code in his machine. So this looks much cooler. My question is sort of echoing other question as well. Let's say my colleague plotted some graph, and I look at it and say, well, obviously you've done the wrong fit, so I want to do something better.
Yeah.
But I want to import at least the data back to my Python development machine to do that. Is that possible?
Yeah, I'll show you. So there's that URL that we were just looking at, and then you can call up py.getFigure with a plotly URL, and that downloads the data. So let's just do this, and then print fig. We have like a pretty print thing, toString. So here's the figure, and here's all the data behind that figure. And you can, we serialize all these figures, basically just as JSON. So in Python, just dictionaries and lists. And so you can interact with figures just as you would like a list. So whoops, that's wrong. Fig.keys. So there's data and layout. So let's check out what the data is. Cool, it's a list. Let's grab the first trace. Here's the X data, here's the Y data. Yeah. And that same interface is available for all the other languages. It's just an API call. Yeah. Anything else?
Yeah, on this data thing, it's a commentary. Something I did when generating mathematical formulas to PNGs is you can actually put comments in all sorts of things, including PNGs. And I put the tech formula,
okay.
Which allowed anybody that wanted to create an unrendered command, turn the formula into the source tech. That's quite useful in publishing systems because often all they can embed is a PNG. Right. But later down the line, you want a high quality version. So you can use the PNG as a placeholder to hold the data.
Yeah. Yeah, and you can also add, let's open up this guy. You can also add LaTeX notes directly into the tool with Plotly. And we'll save them as SVG, and then we'll, so let's grab the equation for this formula.
So you can make SVG a rich thing with whatever you want in it.
Yeah. So this is going to be kind of gnarly LaTeX. Let's just do something simple, like frac. Here's the LaTeX rendering. And so we're using this awesome JavaScript library called math.js to do this, and it saves it as SVG, and you can just paste your LaTeX equations in as notes.
See math.js?
Sorry, math.js. Yeah. Yeah.
Math.js for the labels, sorry, and Newsroom.js for the graphs.
Yeah, math.js for the labels. Yeah.
Right, yeah, so this looks really good from a point of view of taking some charts we produced somewhere and democratizing and sharing it. So that does that use case really well. Yeah. Where do you think next? So there's some kind of obvious possible choices. I'm interested to know where you think you might go. So I mean, one way is to say, okay, well, somebody produced a graph, but actually it's now better in Plotly than in the original code. Maybe. So actually, let's now bypass the original and connect back directly to the source data. One option. Right. Another option is to go into the kind of the dashboarding kind of arena where you've got multiple charts on the same data and you can do more interactive, more like some of the advanced D3 stuff that's been done. That kind of thing is another alternative. Streaming data, connecting into real-time streams, things like that. Yeah. Where do you think next? Maybe on the basis of what I'd like to do, or what we're being pushed to do, or whatever.
Yeah. So our big push right now is sort of a better data API. So the use case is at the University of Copenhagen. There's a quantum devices lab there, and they're using Plotly for their work. And the way they're going to start using it is instead of making a graph in Plotly, they'll make a data set in Plotly. So they're collecting raw data, and then they're streaming that data into Plotly, not as a graph, but just as like tabular format. and then making graphs based off of the reference of that data. So, they're uploading time versus voltage versus magnetic field versus E field, and then creating graphs based off of, okay, this data set, just grab column 1 and column 3 and plot it. Don't actually make a copy of that data, just reference that data set. So then you can have one data set and several graphs linked to it, and you're never accidentally making a copy or accidentally making some change, and if the original data changes, all the graphs will change. And then also introducing like symbolic formulas into this. So a common use case, at least in physics, in my experience, is you have some raw data that you're collecting, but then you want to plot a simple transformation of it. So like voltage times current is power, and you're just collecting raw data, current and voltage. Being able to plot, just say, okay, plot current times voltage. Don't actually compute it, but save that reference. And that's really cool for this idea of like improved data provenance, where if someone has some raw data and then they do several transformations on it, being able to look back in that history of like, what did you do to go from this raw data to the graph that you're showing me? Don't just show me the computed values, but were there some steps on the way? And that's really interesting from like the data journalism point of view too, of having this idea of raw data, transform data in graphs. That's on our immediate roadmap. We also just did, we introduced 3D graphs. And so there's some improvements that we're going to be working on that, but we have some pretty cool 3D surface plots now that are like totally interactive and really fun. So there's more 3D chart types that we can work on, like 3D vector fields, and you can do 3D scatter plots, but other chart types.
And the same philosophy, right? If it's just patterns, the API and all the other. So I wonder if you plug matplotlib, that's okay, or
yeah, exactly. And then we have our own syntax too of this JSON structure that describes graphs. So here, to create this graph, you just put in your Z data, your X and Y data, and you say make a surface plot, and you send this dictionary to Plotly, and then it creates this guy for you. Yeah.
Can you have plots that change over time? So dynamic plots. I was looking at your website, you have an example of Hans Rosling's plot of countries, GDP versus life expectancy, and in the TV program we did, had it changing over a number of years.
Yeah.
You just had it for 1 year. You can actually do that when you have the chance to sort of dynamically change.
Yeah, you can, and we have a version of that somewhere. No, that's not it. But here's an example. What the code is doing for this, actually I'll just show you the code. We have this notebook that's just running on one of like my personal server, and it's solving this this differential equation in real time. Like this server is just crunching some numbers right now, like over and over, solving this differential equation. And then when it gets the solution, it sends that up to Plotly point by point. So if anyone opens this graph, they'll see the same data at the same time. It's being computed live and being shipped up to the browser. So that's possible. There's the other application is like animations, like having a sliding bar, and that's something we're working on now. But being able to ship live updates is possible. There's a great example. This guy's graphing like earthquake data around in Pisa, Italy with a Raspberry Pi and graphing that in real time. Here it is. Yeah, so here's like real time vertical component counts in this, right, like a window away from the Leaning Tower.
How much is the web architecture limiting you in the amount of data you can process with something like Plotly compared to online tools or even online logging?
Yeah, that's a great question. Right now, it's basically limited by how many SVG elements you can draw in the DOM. So it's not as much a function of like the network, but more a function of just the browser. So for scatter plots, we can only plot like 50,000 points before the browser starts to slow down and the interactivity isn't as rich. For line plots, we've done a little decimation, so we don't draw everything at once, but we just, if there are points that are overlapping, we don't draw both of those points, we just draw one of them. And that brought us up to like 200,000 points. But we're not in this area of millions yet.
Is that competitive with, say, D3?
Yeah, so we're using D3 and writing a layer on top of it. Yeah. So, yeah.
So you might not necessarily plot every point if you've got loads of data. They say we've got unlimited open and free graphs. To what extent can we sort of take the piss in terms of just the sheer volume of data? Because in my project, I'm committed to making all my data a book of 5 years. So if you take the job off my hands,
yeah,
I'm not paying the hosting anymore. Is there a limit to that, or is it ameliorated by paying you?
We don't put a limit on it. We'll just eat it, and maybe the network will time out, and we'll give it back to you. But I think people have uploaded like 500,000 rows to the Plotly spreadsheet, and we can draw it, okay. But you're uploading like a 5 megabyte file or 10 megabyte file. It takes a second. Programmatically, you can do the same thing. Yeah, Plotly is an area that I like to call medium data. We're not going into big data yet. Maybe we will, maybe we won't. But just sort of like in the small to medium data sphere right now.
It seems amazing how much you've done in 18 months. How big is your team?
Right now we have around 20 folks. Yeah, around 11 engineers. We've been sort of doubling every few months since last August.
Medical research, how secure is
Yeah, so we're hosted on Amazon Web Services, which a lot of other platforms are hosted on, like Instagram and Dropbox. So it's secure from that point of view. But we've heard this from a lot of folks that some people can't even risk having data leave the network. So like leaving the firewalls at all. Some folks in aerospace are using Plotly just like can't afford that risk. And so then we just install it locally behind the firewall at these companies. And there's no risk of data leaking.
That local install, is that something that you guys do, or do we just download the code and install it ourselves?
Yeah, it's something that we do. Yeah, it's one of the ways that we fund development. We make money. Yeah.
I think we've got time for one more question, or we can make an early charge of lunch.
Can you run network connections?
Not yet. Yeah, coming soon. Yeah. Cool. Thank you so much. This has been so much fun.